diameter 0.15 meters, are in contact with each other, what is the force between them? And that's the density of lead. Ah, no, not juicy, not juicy. Boring, like a plain white toast, or like, yeah. Right. So you have two of these, and the distance between the centers, 0.3 meters. Because the radius, the radius here is 0.15 meters. Right, so according to Newton, F equals G m1 m2 over r squared. But actually these masses are the same, aren't they? They're identical. So I can just write this as G m squared over r squared. And we have density is mass over volume. So mass is density by volume. So this will be G density volume squared over r squared. And do we know the volume? We do. So it's G density 4 over 3 pi r cubed squared over r squared. So if we put all the numbers into the calculator, we can get the answer. What's wrong, Sean?
It's a ball.
It's a ball, yeah. 6.67 times 10 to the power of minus 11. And what's it? 0.3, isn't it?
0.0.
Oh, sorry.
0.0.
No, the distance between the centers is 0.3.
0.15.
That's the diameter. I'm so sorry. It's 0.15 because the radius is 0.075 is the radius. Yeah. Sorry. So okay. Anyways, I should change this now.
What? The radius is 0.1?
Because the diameter is 0.15.
No, the diameter is...
It says the diameter is 0.15.
But when both of them...
0.15.
Yeah. Correct.
The diameter for this one,
Only for one?
Yeah.
for each stem.
But I thought we mix them up.
Yeah, the distance from the center is half hundred and 25 and half hundred and 25.
Okay. 4 over 3 pi. Now this or, be careful, this or on the top, that's the distance between them, and this is the radius of one of them. So this one here is 0.075, yeah. This number, 1.18 micronewtons.
So the below one is 1.5?
0.15, yeah.
Okay.
Yeah?
So 3 case.
Yeah, but not juicy.
Teacher,
Yeah.
can you assume then that's identical? It is not even mentioned the question.
Is it not?
No.
They
No,
have
no,
the
no.
same diameter.
Yeah, same diameter but not same mass. I mean they can make all
Come on,
like
they look made of real.
No,
They have the same diameter.
half right, half wrong. It's reasonable to assume they're identical, but really, really they should have said two identical lead spheres. I mean, it's just good practice. I mean, just because they're the same radius and they're both made of lead doesn't actually mean they're identical. Because as far as you know, one of them could be hollow. One of them you could crack it open, there'd be nothing inside. It does, because it'll change the mass.
But I give only one density, so.
Anyways, that is obviously very small, but I think it's just about at the level that you could actually measure it, perhaps. So you might actually be able to measure this force here. You could certainly measure a millinewton, but could you measure a micronewton? You might be able to.
Teacher, what does the R below usually represent? Like two
The
mass?
distance between the centers.
Two center.
Yeah. Okay, will we do the next one?